Alright, let's have a go at some work solutions here to show what's going on with assignment number 7. And I got a question here. Actually, I don't have one of these on my assignment number 7, but you never know what you might get on your final exam. Alright, what are we told here? We have an experiment to determine the effect of several methods of preparing cultures for use in commercial yogurts. Alright, you're making commercial yogurt, you're using different cultures to do that. 3 batches of yogurt were prepared using each of 3 methods. Okay, I got 3 methods: traditional, ultrafiltration, and reverse osmosis. And for each of these 3 batches were prepared. Alright, a trained expert then tasted each of the 9 samples. I got 9 because I have 3 different methods and we had 3 batches of each. So 3 times 3 gives me 9. Trained expert then tasted each of my 9 samples presented in random order, that's important, and judged them on a scale from 1 to 10. I have no idea what the scale meant, doesn't matter. Partially complete Anova table is shown below. We are asked to state the hypothesis that's being tested. I didn't even ask the question. Actually, the question is there any difference in these 3 methods? My null hypothesis would be that the mean, taste score for traditional is equal to mean score of, what's the other one? Ultrafiltration is equal to mean score of whatever that last one is, reverse osmosis. No idea what this means. Okay, my alternate hypothesis is that at least one of these methods gives a different mean score. Alright, so there's my null and my alternate, and I will fix this up before I publish it. Alright, then we're asked to complete the table. Okay, looking at what you have in your notes, in order to complete an Anova table, and this is an Anova situation because we are comparing the means of 3 groups. Alright, we are told the sum squares for the treatments, where the treatments are the traditional, the ultrafiltration, and the reverse osmosis, and we're told the sum of squares for the random error component. So to fill this table in, first of all, easy part is, let's do the total sum squares. So that must be, those 2 numbers added together gives me 17.76. Okay, that's the total. Now, the degrees of freedom for treatments is always 1 less than the number of treatments. We have 3 treatments: traditional, ultrafiltration, and reverse osmosis. So the number that goes in this block is going to be 2. The number of degrees of freedom for error is always the number of data points that you have minus the number of groups. We have 9 samples, we're told up here, because we got 3 methods with 3 batches. So 9 minus 3 is going to get me 6 degrees of freedom, and if I add those 2 numbers together, I get 8, and this number should always be 1 less than the number of samples that you have. Alright, once we have our sum squares, I'm going to need my calculator here now. To get the mean squares, you take the sum squares, divide by their respective degrees of freedom. So we got 17.3, geez, I should need a calculator for this, divided by 2 gives me 8.65, goes in this block right here. And the next one is the SSE divided by its degrees of freedom. So 0.46 divided by 6 degrees of freedom gives me 0.076666, 0.0766, whatever. Alright, your F ratio. Your F ratio is always the MST divided by the MSE. By the look of it, it's going to be a fairly large number. Alright, we got 8.65 divided by 0.07666666, whatever. And I get, a whopping 102.8. That's humongous. Alright, there should be no doubt that my p-value is 0. However, you were asked, complete the table, don't bother with the p-value, because I'm not getting into using the F distribution in the tables. So we are told that the p-value turns out to be 0.00000017, and it should darn well be small because your F ratio is so big. Alright, we are told the p-value is 0.0000. How many zeros? 4 zeros. 17. Okay, so we've completed the table. Alright, what conclusions can we make if we are using a 1% level of significance? The question always is the same. Is p less than or equal to, in this case, my level of alpha, which is 0.01, and certainly 0.000017 is less. So answer is yes. Reject null hypothesis. And what am I going to conclude? Conclude one, but I don't know which one. One of these treatments, or one of these methods, whatever term you want to use, is different. Okay, once we decide it's different, we generally want to know how are they different, whether the traditional gives me higher, I don't even know what this is. What are we measuring? I don't have a clue. Oh, we're measuring taste. Alright, whether or not the taste is higher for traditional versus ultrafiltration versus reverse osmosis. But in this question we do not have raw data, and we don't have any idea what the treatment means are, so not much we can do on that one. So we conclude one of these methods is different. That's all we can conclude. I have no idea which one's highest, lowest, or whatever. Alright, next question is, what is the residual standard deviation and what does it tell us? Well, the residual standard deviation, that is the S value that you will get from Minitab. And S equals the square root of the MSE. And what is our MSE according to our table? It is 0.0766. So in order to find this out, I would take the square root of that number. And what is my answer going to be? Hang on, I got to get my calculator again. Alright, I want 0.07, yeah, no, there's a bunch of sixes. Take the square root of it, and we get 0.277, let's say. So that equals 0.277. Alright, and it asks me, okay, what is it and what does it tell me? It tells me that on average, the taste scores deviate from their treatment means by 0.277 taste score units, whatever they are. Alright, so I get some idea of the deviation in my numbers. And yes, if I could only spell things would be great. Treatment means. Alright, then we are asked, what assumptions are we making when we make our conclusion? Alright, we've made our conclusion, but our conclusions are based on certain assumptions being met. And what is that? We assume independence and randomization. So I'm assuming, and we were told up above here too, that the batches were presented in random order to the judges. So there is some randomization. We also assume that our groups are normally distributed. We assume the residuals are also normal, and that the residuals and our data show equal variance. Now none of this can I check because I don't have any raw data, but those are the assumptions I'd have to check. And then we're asked, is there anything further we would wish to do with these data? Yes, we would want to know how the groups differ. All right, and that's enough of this one.